Thanks, Nick, for the nice introduction. So I'm going to be talking about MAM deployment in QC for analytical testing and replacement on conventional analytical methods. So first, allow me just to introduce the Merck KJ company. So it's composed by more than 60,000 employees all around the world. We do have three main branches. Myself, I'm part of the healthcare business, and we do operate as a AMD Serrano in the US and Canada. So myself, I'm based in Vevey, in Switzerland, in the Biotech Development Center that is dedicated to the development and manufacturing of biotechnology product for preclinical and clinical study. So the agenda of today's talks, I will be talking about MAM in AMD Serrano, about some regulatory challenges that we have been experiencing in modifying clinical release panel, especially about how we are planning or we are actually replacing the charge variant analysis with MAM, and also specifically about how we have been modifying and substituting the fingerprint concept with MAM. So MAM has been introduced with a well-known publication in 2015 by Rogers. I'm pretty convinced that all biotech have been using this, but for what concerns filing with MAM in GMP release, in my knowledge, there are not that many except Amgen and maybe a few others. So I will be talking about, in my opinion, what's blocking us to put this method in regulated environment. So for who does not know, MAM is a mass spec-based target peptide mapping that allow to relatively quantify product quality attributes that can be like post-translation modification, it can be a degradation product, or protein heterogeneity like clipping or amino acidic misincorporation. So in this slide, you see summarized the 6 main classes of quality attribute that can be monitored with MAM and the conventional method that can be replaced. Because replacing this method is one of the key success of the MAM, because without the saving that comes by replacing the method, the MAM become really hard to sustain. I'm gonna then switch to some experience that we gained in MAM, with MAM in MD Serrano. So before even triggering a discussion with the regulatory colleagues about how to introduce this testing in the filing of a molecule, it's really important to acquire a solid knowledge about MAM is actually performing in your lab. We did it in Vevey by supporting multiple process development, and I just performing a rapid count. I noticed that we recently passed the cap of 10,000 sample tested MAM. So it is not as fast as the DAISY that we just saw in the other presentation. They take more than 1 hour for sample, then you have to add the control, blank, standard, so it's month and month of chromatography. Thankfully, the company heavily invested in automation. You see here on the left our custom design robotic platform that is capable of performing hand-to-hand sample preparation and analytical chemistry. And on the right, the Waters BioCode system that we selected as a platform to deploy mass spec in regulated environment. So I was talking about knowing the performances. It's also a matter of monitoring performances, because if you want to go in a QC, you want to leave not that much space to error. So this is an example of the benefit that you can get from automated sample prep. So it's hard to read, but there are 2 control charts for one of our control that we add at each analytical sequence. The first one is FA2G2 glycopeptide. So the control chart is based on 3 standard deviation that are calculated after 30 data point acquired. And if I correctly read, the lower point, it is 4.9, and the upper, it is 6.2. It is really small. And then below there is the control chart for the methionine 255. Once again, it's really narrow, 1.2, 1.8. So this is really possible thanks to automated sample prep. So now I'm going to be talking about regulatory challenges in modifying the clinical release panel and introducing MAM. So this is the vision that we do have in MD Serrano. The idea is to keep the same analytical platform from research to market, because these allow us to have complete data comparability across all stages. I'm convinced that every time that we modify a method, we lose clearly the data comparability and we lose the knowledge. So I've been doing all that I can to stress on the fact that we should stick with the same method from the beginning to the end. So ideally, we support manufacturability process dev with MAM, where we monitor an extensive list of quality attributes. Then, for clinical release in phase 1 and 2, we need the MAM also to be an identity method, and we monitor few selected glycan oxidation or deamidation modification, and we need to add at this point a new peak detection. We're going to be talking about a new peak detection in a few slides. Then there is process characterization. It's again a non-regulated activities, similar to process development, a phase 3 commercial, where you actually monitor modification for which you have action limit and specification. The idea clearly is to completely replace the conventional method to save and invest in this new technology. I mean, it has to be said, we contacted the enrolled to the emerging technology of FDA to get counseling and guidance in this complex project, and I advise you to do so if you would like to follow the same workflow. So that was the vision. Where are we standing in MD Serrano? So currently, I just showed you we tested thousands of samples in process dev. This is done. My colleagues in Italy have already qualified in GXP environment a couple or even 3 projects with MAM. Process characterization has also already been done multiple times. The only point where we still struggle, it is clinical release. So in clinical release, we still develop charge analysis and reduce capillary gel electrophoresis. And this means that we are not yet ready to fulfill the picture that I was showing you before. So I'm going to try to explain you why. So when we address the substitution method, for example, glycosylation, it's pretty straightforward. You were monitoring release glycan, now you monitor glycopeptide. It's somehow extremely straightforward and easy to do. For what concerns charge variant, it's a bit more complicated. Charge variant, it is a fingerprint analysis, where instead with MAM, you will be monitoring the CQA that created the charge variant. And it's also to be noticed that most of these quality attributes for phase 1 and 2, they are not critical. So it means that you will not have specification for QC release in phase 1 and 2 for these things. So what does it mean? That if you do not have spec for this QA and you stop doing charge analysis, the challenge that we got is so you are getting somehow blind for this stage. Let's see what we can do. So first of all, let's see how the charge analysis and MAM align in our lab with the biocode. So charge analysis, for who does not know, can be done in liquid chromatography or electrophoresis capillary. The protein migrates to the PI, in this case, where has a net charge of 0, and we report the result in terms of cluster to our customer. So charge analysis, allow me to say, it can be an apparent CQA, because the real CQA is the modification that is causing the charge, and this can be detected just by MAM. So this is a list of the most common PTMs that we have been detecting that can affect the charge. So this is a parallel testing that we acquired a couple of years ago to convince our internal customer of stopping doing the charge analysis. It is a crude harvest stability study performed at 22 degrees over a few days. You see on the green left, there is the cation exchange, acidic fraction plotted. On the right, you have the MAM trace of deamidation. So the scale is not the same, but they nicely overlap in terms of trend. So this is really, as expected, overlapping. So on the right, there is a similar slide where they are plotted more deamidation site. You can see that I believe it is the 315 and the 361 are not that much exposed to the solvent, so they are not increasing, but the 389 nicely correlate with the acidic fraction monitoring cation exchange. So with this, we can demonstrate that when there is a big change in terms of acidic fraction, the two technologies nicely correlate. No problem at all. What happens when we do use the charge analysis to support process development? In this case, the excursus is much lower. It's not a stability study, and nothing big is happening in our sample. We performed a DOE study in double testing, then we treated with the PCA. In summary, when at the conclusion of the correlation, we noticed that all clusters are positively or negatively correlating with the presence of the lysine C-terminal. So at the end, we have been doing this control strategy, this method in the control strategy for years, and we have been monitoring what the C-terminal lysine that we all know is not critical, so not that useful. And in conclusion, here the data are not shown for a matter of time. When the same experiment is performed with carboxypeptidase, we clearly see that in this case the eyes is not capable of detecting fine modification induced by a DOE study during an upstream process development. So now that we know how the two technologies correlate in terms of numbers, I'm going to be talking about the fingerprint concept. So we said, what I said, one of the biggest challenges that I got internally by our regulatory colleague is if you do stop performing eyes, you will lose this fingerprint view, and we expose the project to a risk. So how can we solve this? But thanks to the new peak detection. So new peak detection, it's a part of a MAM workflow that output retention time and the deconvoluted mass of the potential impurities in a sample when it's compared against a reference. So here on the left, you see the parameters that are available in the Waters peptide mapping application that is specifically developed for use in a regulated environment. We can adjust the fold change that we want to use as a threshold to detect, to highlight a modification. We can adjust percentages based peak response. So this means that it's going to calculate and highlight just peak that are more than 1% respect to the highest peak detected. We can match retention time and exclude ions that are present just in one state of charge. So new peak detection really allows to substitute this charge analysis fingerprint, especially in my opinion, for clinical QC release where you have no other spec and you don't want to be completely blind. So in order to set up these parameters, we have been doing some experiment. My first suggestion is try to do not overdo with this new peak detection. There are some nice publications available on the internet. But the point here is not to demonstrate that you can detect 20 femtomole of UPS standard in your control, because we're not doing that. Here you need to adjust your parameters to do what the eyes was doing. Be sure that your batch to batch is consistent. Because you don't want to be called by QC colleague every week because you have an out of spec. So what we did, we performed an increasing amount of stress samples spiked into a control, and here we plotted the result as they are produced as they are showed in the peptide mapping application. So it is really nice and user-friendly. We got the amidation result, top left. As expected, they are extremely stable. The oxidation is not impacting the amidation. I have to say that the peptide mapping application uses a consistent isotope selection for peak integration. And you can also select the number of charge stated you want to extract every time. It is really useful and it allows to really reduce the RSD. For what concerns oxidation, you clearly see that it's ramping up the more you spike, makes perfectly sense. When you click on the histogram, the software automatically shows the spectra and the isotope that have been included in the calculation so that you can check that everything is fine before releasing result. Then for what concerns the new peak detection, here we got the histogram with the number of new peak that has been detected with this detection criteria highlighted in the stress study. By clicking on the histogram, the software shows all the peak, all the compound that have been detected as a new. In this case, I mean, you can always get the convoluted mass, retention time, charge state, and even the fold change. By clicking on the line, the software output the ion chromatin restriction. You see in orange the unknown sample where it's pretty high. We also see that it was present in the reference but was extremely low. So at this point, you can confirm into the software that it is a new peak. And the second step is to understand what actually is. So in this case, you need to use Unify, that it is the discovery platform available on the Biocode. And by looking for the compound mass, we understood that it's a miscleavage due to the oxidation state that is pretty high in the stress sample, so nothing special, but the software nicely did the job. So now that we discuss about how we can substitute charge analysis and introduce MAM in clinical QC release, there is one last step. It is to convince your computerized system validation colleagues that the application and the software will fulfill all the requirements for GXP purpose. I have to say that peptide mapping software is really developed to do so. It's extremely easy. It has all the function required, and it does not have all the function that you don't need. Because in this case, there are several things that you don't want to do when you are in the QC. For example, the things that I like most in this application is that once you created a processing method and you use to process your data, you cannot modify your processing method by mistake while you are doing it. If you want to modify the method, the only way to do it is to exit the analysis, go and create analysis from existing method or from scratch. So you are actively choose to do so. What does it mean for who has experience in QC? It means that every month when your QA will ask to go through the log file of your GXP analysis, there will be no surprise because nobody might by mistake modify the method. So in conclusion, in MD Serono, we developed an high throughput MAM method to support development stage and process characterization that can be streamlined to QC. We have been in contact with the FDA to include it as a unique test also in clinical stages. New peak detection is essential part of the purity assay, a phase 1 release. It allows to replace the charge analysis fingerprint when no spec are yet set. And the peptide map application workflow with new peak detection can really ease the introduction of mass spec in regulated environment. Thanks for listening. I don't know if you take question or no.